Hello everyone, my name is Robert J. Fortunato Jr. I'm here to review the PoLR feature for BreazeHome, its current shortcomings, and the development wish list. In particular, we're going to look at what improvements we could have had in the current release, and what would future product features look like. Team PoLR consists of Jose Sobalbarro, Juan Garcia Torres, myself, the speaker and presenter today, Shu Li, our Scrum Master. Before we get into the video content, I'd like to introduce what it is we're going to discuss today on a high level. Overall, we see two shortcomings, the first really being the impact of throttled Google API calls on the overall end-user experience, and the other being a convergence anomaly that we found during the implementation when using Google source data. Everything else is a wish list item, which includes minimizing Google API calls through caching, moving beyond the Miami mindset for commutes, obtaining an unlimited key for high performance and high resolution PoLR searches, moving into a mobile world, and then finally a quick conclusion. The first shortcoming we'd like to talk about as it relates to PoLR is what the impact of throttled Google API calls is on the overall end user experience. At the end of the day, we've written a software product that needs to be used and consumed by users. That experience has to be enjoyable and productive. If it isn't, then we failed. One of our key shortcomings is in that area, and we'll get into the details of why. To start off, I'm going to use the production website to demo the PoLR search feature in action. We were fortunate enough to produce quality code for our deliverables, and it was integrated into the mainline codebase and released. Going to the BreazeHome website, I'm going to put in a search address, FIU, pick Wednesday as a commute time, say I'd like to live maybe 15 minutes by car from FIU, and I'd like to get there at 8:30 in the morning. I'm assuming that everybody's watched the PoLR video on how PoLR works from the introduction. So I'm just going to apply the filter, and we're going to have PoLR go off, run the search, generate the polygon, and produce the results. You'll notice this was really snappy. You'll also notice the resolution on the polygon is very simple. It's a triangle. We'll get into some of the details in a little bit, but this sets the stage for the first shortcoming. To keep the demo concise, I've already teed up a PoLR search, except this one isn't in production. This is on one of the development VMs that the team worked on. Again, it's FIU Wednesday, 8:30 in the morning, 15 minutes by car. I'm going to go ahead and apply the filters, but one of the things about this one is it's going to cook in the background. I can actually talk for a little bit and still not get a result. If you think about what the other one looked like in production, the triangle, very snappy response, great user experience. This, on the other hand, is not so great a user experience. It took quite a while longer to get that isochrone back, but as you can see, it's a much higher quality isochrone than the triangle. It maps closely to the main avenues, highways, streets that one can take to get to FIU and be there in 15 minutes on a Wednesday morning at 8:30. For the price of more time spent generating the algorithm, a poorer user experience, we get a higher quality result. In our opinion, that's a really big shortcoming. In an ideal product, you'd have the best of both worlds. You'd have a great high quality isochrone, detailed search, very well converged, showing users lots of properties and nice outline of where they can live, and it'd still be snappy response. We'll get into some of the specifics on why the difference in behavior is there, and we'll demo some of the API limitations in code that leads to this. The first place to start with understanding this behavior is to go to the Google Maps Distance Matrix API documentation and look at some of the usage limits. The Google Maps API is one of the tools we used in the algorithm that generates the isochrone for a PoLR search. If we look at the standard usage limits, we'll see that there's 100 elements per request limit. We also see that there's 100 elements per second limit, and that's across all requests independently. If you think about what a PoLR search is, it generates a polygon where each point in the polygon is an angle in a circle, ultimately a request to the Distance Matrix API to map out how far we can go in traffic for a given period of time. The net result is the more angles you use, the higher resolution isochrone you get, the nicer the image is for the end user, but the closer you come to doing the 100 elements per second. There are some options around premium usage limits that let us do higher resolution with more requests. We'll get into that because that's a wish list item. But right now, looking at the standard usage limit, we do have a throttle here that's artificially imposed on us, and that's as a result of the Google API limits. The next shortcoming that we'd like to discuss is that of a convergence anomaly in the PoLR algorithm for generating the search polygon when using Google source data from the Distance Matrix API. In particular, it manifests itself on corner cases where we're searching for properties or commute times that are near oceans, swamps, mountains, or deserts. In short, the corner case is we're near the edge of something that's habitable and it's bounded by something inhabitable. We'll demo some of the shortcomings and details now. I'll start off demoing the shortcoming by picking a different polar search, but we're going to start in production. This time we're going to use Miami Beach, same Wednesday, 8:30 a.m. by car, 15 minutes. Going to apply the filter. Notice the time it takes to generate the polygon this time around. Substantially higher. That's because this particular shortcoming actually aggravates the first shortcoming we were talking about earlier. Notice this particular polygon here. It goes off into the ocean. Now, from a property search perspective, this isn't a defect. There are no properties that sit in the ocean that can be bought or rented, and that's okay. But from an algorithmic efficiency perspective and from a polar implementation perspective, the Google data actually finds that the properties right along the beach, especially those nearest to the point, are reachable in much less than 15 minutes. The polar algorithm takes that data and says, hey Google, give me another point. I want to keep searching. Google pushes out, and for a certain amount of distance offshore from the beach, or take the swamp for a different case, Google will actually return a set of points, indicate a drive time, but the drive time is very, very high. We believe this to be a defect in the Google Matrix API. However, this is something that was unaccounted for inside of Polar. It's a shortcoming, and in particular, it compounds when we use more angles. I'm going to take the same search, except this time we're going to do it with a 32 angle isochrone, the one that took a lot longer the first time when we demoed the previous shortcoming. And as you can tell, this one's really taking its time. So not only is the polygon off in the ocean where we can't find properties, we're really impacting the user experience here. Having the hindsight of some of the shortcomings in the Polar implementation, we move on to the wish list items that we'd like to see. In particular, minimizing Google API calls through caching of the response from the distance matrix web service is something we think would be high value, both from a user experience perspective, but also from a cost management perspective for API calls to Google. Going back to our demo application, before we rerun the search, one of the things I'd like to demonstrate is the API call rate. Right now we've executed 3,324 API calls. Earlier in the video, I demoed how FIU could search with a 36 angle isochrone. So I'm going to go back, same date, same time, same commute mode, same commute time. I'm going to apply the filter for FIU. Going to give it a moment to generate the isochrone. It's going to go out, call Google again. But these are results that we should already know about. Either I've generated them myself or another user somewhere else in the BreazeHome space has already made this call. If we flip back to the API, we look at the 3324. It takes a moment for the API to update, but if we think about a common use case for users would typically search for common property areas that they want to live by. Think Miami International Airport, Miami Beach, Aventura, Brickell, FIU, University of Miami, Kendall. It's quite conceivable that a user of BreazeHome looking for properties has already searched for a commute time search. A lot of people want to work downtown. They will have to be there by 9 a.m. It's quite conceivable that that polygon data is already going to be cached, and we don't have to incur the extra polygon calls to Google's API that now are showing up in the Google quota matrix. Caching not only improves the user experience from a performance perspective, the results are already there and we don't have to pull them up again, but it also helps manage the key usage. Moving on with the wish list, another feature we see as very utilitarian is the one that takes us beyond the Miami mindset for commutes. In Miami, we're all about our cars. That's why traffic is so bad. Mass transit doesn't really go somewhere people want to go. But expanding BreazeHome beyond Miami and using the Polar search features to generate isochrones beyond Miami would really bring in mass transit options like subways, light rails, other mass transit options that you can find all around the country, just not here in South Florida. We didn't implement any of the transit features, but if we go into the developer's guide for the Google documentation in the Distance Matrix API, one of the things we see is there's a mode parameter. When we've done driving, we've done bicycling, we've done walking, but there is a transit option. And with the transit option comes the option to also select a transit mode. In particular, the transit mode provides for bus, subway, train, tram, rail, or combinations thereof. And it also allows for routing preferences as it relates to transit. How many transfers you're willing to take? Do you want more or less walking? And it assembles for you a route in terms of a commute that you can use to get to and from home, work, or any other place you're interested in for a polar search. This would require some work in the UI. It also requires a little bit of logic in the back-end Polygon to generate, but we think moving beyond Miami, this is a very nice feature to have for Polar. The next wish list item is all around an unlimited key for using high performance and high resolution Polar searches in BreazeHome. Of course, looking at some of the shortcomings and some of the throttles we've put in to keep from blowing out the API query limits, this requires a little bit of work or some money. Work for this particular wish list item is something we already started on Team Polar. As you saw in the earlier video, API key usage can stack up quickly, especially when you're using high resolution isochrones that have lots of angles. We reached out to Google, and the response was very favorable when we inquired about sponsoring the Polar project and FIU under an API key that had premium use right entitlement, but still would be free of charge. They responded that since FIU and the FIU Foundation are a 501c3 organization, not for profit, we'd be eligible if we registered for the Google Nonprofits program. So we did a little bit of digging. We found the IRS determination letter on the FIU website, and in 1969, the FIU Foundation was granted 501c3 status. All that needs to be done, to finish off this wish list item, is to follow up with Mr. Stephen Lewis after we reached out to Dr. Sajadi, so that Mr. Stephen Lewis can go ahead and put together the paperwork needed so that we can register the Google API key under FIU Foundation's not-for-profit 501c3 status. So if you find yourself working on future Polar feature sets and the API calls start to stack up and you don't want to pay for them, here's an opportunity to finish off the wish list item, help everybody out. Our last remaining wish list item from the V1 release for Polar is to really look at it and make it a mobile feature set. It's a mobile world out there, but Polar was implemented in such a way where it's right now only in the desktop UI and in a reusable API that supports a future mobile version. As far as the mobile UI is concerned, there really isn't much to demo here because it doesn't exist. That's why it makes our wish list. What we'd like to see is somebody take this and pick it up, and for a V2 Polar feature release, implement the mobile UI. What we'll do is we'll review the architecture implementation that makes it easy to do this for a future state, so that anybody who picks it up understands where to go with it. The pieces we implemented were really the desktop UI and the search case right here, search properties, which can use a commute time filter. The logic for generating the isochrone, which produces the polygon that bounds the property search, also produces the polygon that gets overlaid on the map, is a back-end REST API call. Once that's returned to the search properties use case, it gets passed back into the REST API, where properties are searched by commute and any other filters the user wants. All of the heavy lifting has been done. We've left the BreazeHome mobile UI grayed out because it didn't get implemented for lack of time. However, the same use case, search properties, it includes the commute time filter, call the isochrone, get that, send it to the back-end search properties by commute and filters, gives you a mobile UI. It just requires some work in terms of layout and UI coordination. In conclusion, we'd like to thank you for taking the time to look at the shortcomings and the wish list items we've left behind. We're excited with the work we did as Team Polar. We also think that there's exciting opportunities for a future feature V2 release for Polar. Not only can we fix some of the shortcomings if this were to be picked up, and can we get some of the wish list items knocked out, but if we look at some of the cross-pollination between the features that got released from other teams, things like the Spotify team in particular, there's real interesting synergy there to search Spotify items, find what restaurants are within a given walking distance or commute distance using the same Polar search algorithm. Again, thank you for the time. We hope you enjoyed, and good luck.